Alright, we're here at gotomath.com. Click calculus. Let's go down to concavity and the second derivative test. Of course, that's what we're going to be using. Is the second derivative test for finding max or min in this problem. And it says it right up here. Use the second derivative test. So in the earlier parts, we found relative extrema, that's maximum or a relative minimum. And we did it by using the first derivative. However, we're going to show it by using the second derivative, that this right here is actually going to be a relative. Now relative means just relative to this area right here, okay, relative to this area right here. A minimum, right, a minimum. And we call this being concave up, so remember that. Okay, so remember when it's concave up, remember when we took the x value, plugged it into the second derivative, it was positive. So that's going to mean that it's concave up right here, which means it will be a minimum. But let's go ahead and move on over to the whiteboard and write all this stuff out. So we have x minus 5 squared plus 4. So yeah, 11-1, making sure. X minus 5 squared plus 4. Okay, right, x minus 5 plus 4. Okay, so we're going to take the first derivative, bring the 2 out front, subtract 1 from the exponent, derivative of the inside, bring it out, is just 1, derivative of 4 is 0. And then we'll take the second derivative, but you know what? Best thing to do, take the first, let's just go ahead and distribute that 2 across. So we have 2x minus 10. So the derivative of 2x is 2. Derivative of 2x is 2. Okay. Now, so we took all three of the derivatives here. Okay, or all three of the derivatives. We took the first derivative and the second derivative. But what we'll want to do is get the critical number from the first derivative, remember that? And so, in other words, we set that first derivative equal to 0, get that critical number. The critical number happens to be what, 5? Okay, plug 5 in, you get 0. So that's the critical number. Okay, so we plot the critical number on the number line. But now all we have to do here is really take this 5 and plug it into the second derivative. And of course, there's nothing to plug it into right here, right? It's 2. And remember, all we care about is if it's positive or negative, and this time it's positive. We've got a positive number here, all right? So in other words, if this is positive, then we know that it's going to be concave up right here, okay, concave up. And if it's concave up right here, well, this is going to end up being what? A minimum. This will be a minimum, and of course we're looking at just, you know, this is actually the graph here. That's right. So we're looking really, remember we talk about relative, we're talking about this is a ball about a point. No, I shouldn't say that, but anyway, technically it is. But anyway, we're talking about just this little small area right here, okay, more or less. Um, anyway, so there it is, right? So we can do that. That's all we have to do. We don't have to do the increasing, decreasing thing at this point. We can just take this number, plug it in to the second derivative, and be done with it. Yeah, so that's another way of looking at that. Okay. So anyhow, it's relative. Oh, they're going to want the point, aren't they? I forgot about all that. So the actual, so we know that this is a relative minimum, and we're looking at the point here, 5, and of course you want to take 5 and plug it in up here. I'm just going to write f of 5, which is actually going to be 4. Right, plug 5 in, you get 0, and you're left with 4. Okay, we can see that. 1, 2, 3, 4, 5, 4. 1, 2, 3, 4. Okay. It's always nice to look at a picture. Let's make sure the answer is correct. Relative minimum 5, 4. Okay. So we can use the second derivative to find relative mins and maxes. Alright, well, we're here to go to math. You can come on over, check that out, and maybe I'll see you there.